Welcome to Mathematics Made Easy with TADX, where mathematical concepts will be explained in clear terms for easy understanding. You can also join us on all our social media handles for more information.
All right, good day, pause. Last week we started the simultaneous linear equation, and precisely we were able to take the elimination method. So for today, I'm still going to take the elimination method, but what we are going to do is that we are going to look at another set of questions. And if you look at what we have here for today, we're having a particular question there that is having fraction. That means you have fraction as part of the question. What you are going to do is very simple. Just follow the procedure that you are going to use today to solve this. So with that, you'll be able to solve any question that is in fractional form as far as simultaneous linear equation is concerned. And if you look at this second part of the question, the second part of the question here, we are having mixture of variables here. Here we have x, we have y, and the constant is also on the left hand side, as opposed to what we did the last time. Now, what we did the last time was that the constant was on the right hand side strictly. But for today, what we are going to be doing is that we are going to also be considering a particular question where we have the variable on the left hand side and we also have the constant on the left hand side. So when we get to the question 2, you are going to see the way we are going to do it. So let's start with this question 1. And for the question 1 here, you have 2x minus 1 over 2y equals to 4 number 1 over 2 for our equation 1. And we have x plus 1 over 5y equals to 0 for our equation 2. So let's see the way we are going to evaluate it. We have 2x minus 1 over 2y equals to 4 number 1 all over 2. Then we have x plus 1 all over 5y equals to 0. So still working on the elimination method. In this case here, since we are having two variables, what I told us the last time was choose a letter of your choice that you want to eliminate. Either you are going to eliminate the x or you are going to eliminate the y. But in this case here, if we are choosing the x, it would have been very, very easy for us. Now, I want us to work with this fraction here, because when you're working with fraction, it's a bit cumbersome, or let me say it's a bit complex, and that's why I want us to take this particular topic again, so that when you have questions on fraction, you'll be able to know how to evaluate it. Now, when you have the fraction, here we have 1 all over 2y, and here we have 1 all over 5y. That means the coefficient of y in this place here is 1 over 2, and the coefficient of y here is 1 all over 5. So what we just need to do is very simple. For this one that is our equation 1, and this one that is our equation 2, multiply this equation 1 by 1 all over 5, then multiply the equation 2 by 1 all over 2. That's the coefficient of y that you have here. Use it to multiply your equation 2, and the coefficient of y that you have in equation 2, use it to multiply everything you have in equation 1. So that means I'm going to be multiplying everything in this my equation 1 here by 1 all over 5, which is the coefficient of y here, and everything in equation 2, I'm going to be multiplying it by 1 all over 2, which is the coefficient of y in this place here. So let me write it here, my 1 and 2. So here I'm multiplying by 1 all over 5, and I'm multiplying by 1 all over 2. And take note of this: when you are multiplying this 1 over 5, which is the coefficient of y here, you are using it to multiply each of the variable. So that means I multiply 1 over 5 by 2x, and I also multiply 1 over 5 by 1 over 2y, and I'm also multiplying 1 over 5 by 4 over 1 over 2. So when you do that, I'm going to be multiplying it outside there, then I'll be writing my values here one after the other. So let's start with the first one: 1 all over 5 multiplied by 2x. So here we have 2x dot 1 all over 5, where this dot stands for multiplication. So this one is the same thing as all over 1. 2x times 1 gives us 2x divided by 1 times 5, which is 5. So here I'm going to write 2x all over 5. I'm done with the first variable. My minus here, I'm still going to put the minus, because I'm not using the minus to multiply for now. Now, the next thing I'm having is 1 all over 2y, 1 all over 2y multiplied by the 1 all over 5 that we have here. So if I'm multiplying, this 1 all over 2y is the same thing as y all over 2 multiplied by 1 all over 5. Now, how did I get that? For me to get this 1 all over 2, changing this to y over 2, I multiply this numerator by this y. So that means 1 times y gives me y, and that's the same thing as y all over 2 multiplied by 1 all over 5. So just like what we did here, y times 1 gives us y, then 2 times 5 gives us 10. So I will come down here, write my y all over 10, then everything equals to, now coming back to what we have here, 4 whole number 1 all over 2. I'm multiplying it by 1 all over 5. Now before we multiply this, first of all change this mixed fraction to improper fraction. 4 times 2 is 8 plus 1 gives me 9. So this is 9 all over 2 multiplied by 1 all over 5. 9 times 1 is 9, then 2 times 5 is 10. So that means I'm having my 9 all over 10. Before I go to my equation 2, let me still recap or summarize what we did. Now, when we started, I said you can either start with your equation 1 or equation 2. That means making use of either x or y. Now, here we decided to make use of y because what I did was I want us to take the fractional form. Because if you are taking this x is just whole number. You can just say this one is 2, this one is 1. Multiply everything here by 1, multiply everything here by 2. Whole numbers are very easy to evaluate, but I want us to take the one that is a bit complex because we are reviewing this particular topic, taking it again. So if you are reviewing it or taking it again, the essence of doing that is for us to be able to solve complex questions, so that by the time you start solving questions on your own, you know, say, when they were doing the example, they did it like this, or they treated only the simple questions in the example. So what's now happening? Why can't I solve this? So if you're able to go through the procedure, you should be able to get it. Now, we started with this y, and the coefficient of y is 1 over 2 here. The coefficient of y here is 1 over 5. And our goal is to make the coefficients for both equation 1 and equation 2 to be the same thing. That's for the letter you have chosen. Now, I've chosen y here. So I decided to multiply everything in equation 1 by the coefficient of y in equation 2. And the coefficient of y in equation 2 is 1 over 5. So I wrote it here. That means I'm multiplying everything in equation 1 by 1 all over 5. Now, going to my equation 2, the coefficient of y here is 1 over 2. So I'm multiplying everything in this equation 2 by 1 over 2. And that was how I wrote it here. So I started multiplying. 2x multiplied by 1 over 5 gave us 2x over 5. I wrote it down. 1 over 2y multiplied by 1 over 5 gave us y over 10. Then equals to 4 whole number 1 over 2 multiplied by 1 over 5 gave us 9 all over 10. So we go to our equation 2 now to multiply. So I start with this first one, which is x multiplied by 1 all over 2. I can even use my dot. Either use your dot or use the multiplication, you are still using the same thing. Now, x multiplied by 1 gives you x divided by 2. So that gives me x over 2. Now, I'm having my plus. I put the plus there. 1 all over 5y multiplied by 1 all over 2. The same thing I did earlier. 1 times y gives me y all over 5 multiplied by 1 all over 2. Y times 1 is y. Then 5 times 2 is 10. So that gives me y all over 10 equals to, now 0 multiplied by 1 over 2. Anything multiplied by 0 will still give you 0. So I put this one here as my 0. So after going through this procedure of multiplying by 1 over 5 and 1 over 2, you can now observe that the variable of y here is now having the same thing. Or if you look at it very well, in case you are not seeing what I'm saying, let me bring it out and make it visible for us. For equation 1, we have minus y over 10. And for equation 2, we have plus y all over 10. I decided to include the signs this time around because we are going to come back to a particular sentence I gave us in our last class. But before the sign, let's look at this now. When you have y over 10 and y over 10, this y over 10 is the same thing as 1 all over 10 y. Because from what we did initially, we multiplied the 1 by y to get y all over 10. So that means the coefficient of y here is 1 over 10. So either you use 1 over 10y or you just use it as y all over 10. You are still saying the same thing. That means the coefficient here now is what? 1 all over 10, which is still the same thing that we have here. So that means our equation 1 is minus y over 10 and equation 2 is y over 10. Now, since we have the same value now for the coefficient of y, let's now look at the signs here. We have minus here and we have plus. And from our last class, I gave us the same things, that you are to add when the signs are different or when the signs are not the same. Then you are going to subtract when you're having the same sign. Here now we're having minus and plus. The signs are not the same. So that means we are going to be adding equation 1 and equation 2 together. So if I'm adding both of them together, I'm going to start with the variable of the x. I will add the x in equation 1. I will add this to the x in equation 2. So that becomes 2x over 5 plus x over 2. So that's the variable for x. Now taking the variable for y now, we have minus y over 10 plus y over 10. Automatically this one is gone. And that's where the elimination is coming in, because minus y over 10 plus 1 over 10 is 0. So automatically it's out of it. So the number after the equality sign now, we have 9 over 10 plus 0. And 9 over 10 plus 0 will still give us 9 over 10. So where the work lies now is 2x over 5 plus x over 2. Let me solve that here and we'll see what we are going to have. So when we have 2x over 5 plus x over 2, the LCM here is 10. That's LCM of the denominators, which is 5 and 2. So since the LCM of the denominator of 5 and 2 is 10, how many 5 will you see in 10? 2. Now multiply that 2 by the 2x we have here. That gives you 4x. Then plus, how many 2 will you see in 10? 5. 5 times x gives you 5x. So we can now add the numerators here now. 4x plus 5x, that gives you 9x all over 10. So that means what we are having here now for this 2x over 5 plus x over 2 is 9x over 10. So I bring it out now. 9x all over 10. Now this minus y over 10 plus y over 10 is cancelled out. So I'm going to my equality sign now. Equals to 9 over 10 plus 0. That still gives you 9 all over 10. So that means our solution is now reduced to only variables in terms of x. So when you have variables in terms of x, nothing like y here. So to make work easier for ourselves, we can just cross multiply, and you can still look at the board and just tell us the answer directly. But let me still be going stepwisely. When you cross multiply, you multiply this by this, multiply this by this. So we have 9x multiplied by 10 equals to 10 multiplied by 9. 9x times 10 gives you 90x. Then 10 times 9 gives you 90. Dividing both sides by 90. So we have x equals to 1. So that means we've been able to get our answer for x as 1. Now since we've gotten our x for x as 1, we can now substitute the value into either equation 1 or equation 2. In our last class, I think I was making use of equation 1 often. So today I'm going to make use of equation 2. So like I told us, you can either use equation 1 or 2 and your answer will still be correct. So using my equation 2 here now, I'm going to have x plus 1 over 5y equals to 0. Now, anywhere I'm seeing x, remember that we've gotten our x as 1. So I'm going to replace this x here by 1. So this now becomes 1 plus 1 over 5y equals to 0. So that means I've eliminated the value of x here now. Instead of me having x, I've replaced it by 1. Nothing like x is in the question again. But here, 1 that is here is having invisible plus. When it crosses to the other side, it becomes minus 1. So I'm having 1 over 5y equals to 0 minus 1. And from our direct number that we started with, 0 minus 1 gives us minus 1. So we don't need to waste our time. So this one is still the same thing as y over 5 equals to minus 1. And this is the same thing as all over 1 when you write it in fractional form. Any number that is standing as whole number, take for example 10 is the same as 10 over 1, 4 is the same as 4 over 1, 7 over 1. So minus 1 is the same as minus 1 all over 1. So to get our final answer now, cross multiply. Y times 1 equals to minus 1 times 5. So y times 1 gives you y equals to minus 5. So therefore you can now say your x equals to 1 and your y equals to minus 5. So let's check and see if the solution is correct or wrong. And to check, like I told us in our last class, you can either use equation 1 to check or use your equation 2 to check. So here, let me use equation 1 to check. We have 2x minus 1 over 2y equals to 4 whole number 1 all over 2. and our x here is 1. So anywhere you see x, you replace it by 1. 2 into bracket 1 minus our y is minus 5. That's 1 all over 2 into bracket minus 5. Everything equals to 4 number 1 all over 2. 2 brackets 1, that's 2 times 1, which gives us 2. Minus times minus here is plus. We have plus. Then here we have 5 times 1, which gives us 5 all over 2 equals to 4 whole number 1 all over 2. I told us not quite long that when you have a number standing on its own, if you want to turn it to fraction, it becomes over 1. So that means this one is the same as 2 over 1. The LCM of 2 and 1 here is 2. How many 1 will you see in 2? That's 2. Multiply it by the 2 that is here. That gives you 4 plus. How many 2 will you see in 2? 1. Multiply it by the 5. That gives you 5. Everything equals to 4 over 1 all over 2. 4 plus 5, 9 over 2 equals to 4 over 1 over 2. So how many 2 will you see in 9? 4. Remainder 1 all over 2 equals to 4 over 1 all over 2. So that means our answer for LHS is the same thing with what we have for the RHS. And just like the way we have been doing it, if your answer for the LHS is the same thing with the answer for the RHS, then that means your answer is very much correct. So that means what we've done here, we have gotten the answer for X as 1 and our Y as minus 5. Okay, so for the second question here, was the one I told us initially, that both the variable and the constant is on the left hand side. And the normal way simultaneous equation is supposed to appear is that you have the variable only on the left hand side, while the constant will be on the right hand side. Now when you say constant, what I call constant here is a number that is not having a letter together with it. That's what we call the constant here. Now in this case here, we have 3x, that's the variable. 5y, variable. 5 is the constant because there's no letter together with it. So that means this letter needs to go to the right hand side where it belongs. Now 4x is a variable, minus 7y is a variable. 8 here is the constant. 8 needs to go to the right hand side where it belongs. So that means what we need to do here is to rearrange. So when you rearrange, we have 3x minus 5y equals to 0 minus 5. That's for equation 1. Then equation 2, we have 4x minus 7y equals to 0 minus 8. We are not through with that. We can still rewrite it. So we have 3x minus 5y equals to 0 minus 5 gives us minus 5. Then 4x minus 7y equals to minus 8. So I can still call this my equation 1 and I can still call this my equation 2. And if you like, you can call it equation 3 and you call this one equation 4, depending on you. That means if you have labeled this as your equation 1, label this as your equation 2, you come back to this place after rearranging it, you call this one your equation 3 or you call this one your equation 4. And it's also possible, if you don't want to use a number, you can call this one your equation A, call this one your equation F. If you are using equation A, equation F, or any letter of your choice, it's just for you to make reference. By the time you are making reference, you say, okay, from equation A. That's if you have called this your equation A, and if you have called this one your equation F, you say from equation F. That means you are no longer going to be working with equation 1 and equation 2, but rather it's going to be equation A and equation F that you are going to be working with. Now, while rearranging here, it's also possible for you to see questions like, maybe they give you something like, let's say 2x plus 7 equals to 4y. That's for your equation 1. Then we have 3y plus 6x equals to 8 as your equation 2. If you look at this type of question here, this standing as your equation 1 and this standing as your equation 2, logically you may say it's not correct, but rather mathematically it is correct. What you just need to do is just for you to just do the same thing we did here, rearrange. When you arrange, that means you are going to place x under x, y under y, then the constant goes to the right hand side. So this now becomes 2x. Now this 4y comes inside, but here is having plus. When it comes, it becomes minus 4y equals to this plus 7. When it crosses, it becomes minus 7. Now in this case here, y is the expression that is starting. So when you rearrange, this x should be under x, but the x here is still on the left hand side. It has not crossed the equals to, so it's still going to retain its sign as 6x. So we have 6x. You don't need to put the plus. because we already know that plus is the one that is starting it. Now 3y, that is here, 3y is also on the left hand side. It has not crossed this equals to, so it's still going to retain a sign that is having here, which is plus 3y equals to the right hand side, which is the constant, equals to 8. So when you rearrange here now, you see that x is under x and y is under y, and the constant is under each other. So irrespective of the way they rearrange the question as far as mathematics is concerned and this topic itself is concerned, what you just need to do is rearrange. After rearranging it, then you can continue your solution. So let's see how we proceed from here. So the next thing we need to do now is very simple. From our equation 1 and equation 2, when you consider the values of x, the x here is having 3 and 4, the y is having 5 and 7. Both variables, they are not having letters that are having the same coefficients. 3 and 4 are not the same, 5 and 7 are not the same. So you cannot choose any letter of your choice, the one that you want to be the same thing. Is it x or y? Initially, when I was in the first one, I started with y. So let me start with x now. So if I'm starting with x, that means I want to make my x to be having the same value. Here, for equation 1, we have 3x, and equation 2, we have 4x. So if this is standing as your 1, and this is standing as your 2, what you're going to do is this: take this 4, use it to multiply everything in equation 1. Then this 3, use to multiply everything in equation 2. So that means for this my equation 1 here, I'm going to be multiplying it by 4. Then equation 2, I'm going to be multiplying it by 3. That means each variable that is there. So let's multiply each of the variable. So we have 3x multiplied by 4. That gives us 12x. We have 5y multiplied by 4. Don't forget we still have minus here. So if I put the minus, 5y times 4 gives you 20y. Now equals to minus 5 times 4. That gives us minus 20. Now 4x times 3. That gives us 12x. We have minus here, so I'm putting the minus. Now 7y times 3. That gives us 21y equals to minus 8 times 3. That gives us minus 24. Now after doing that, we have been able to get the same value for the coefficients of x. Both of them, they are now having 12 and 12. Now if you consider the sign that we're having in the front of the two numbers that are the same, which is 12 and 12, both of them are having plus and plus. And you may be asking, why is it plus? There's an invisible plus here, invisible plus here, which will not be written. You are not seeing it there, so you don't even know that it exists. But as a mathematician, you know that there's an invisible plus here in both of them. So when they're having plus and plus, the signs are the same. So that means we are going to subtract. So I'm going to be subtracting equation 2 from equation 1. So that means I write 12x minus 12x. Now minus 20y minus, there's another minus here, so I open another bracket, minus 21y, then equals to, here I'm having minus 20 minus, open another bracket before writing this minus, minus 24. So I close the bracket. Now 12x minus 12x is gone because that's 0. So here now we have minus 20y, minus times minus is plus 21y equals to minus 20 minus times minus plus 24. So we are back to direct number. Minus 20y plus 21y, that's 1. So you just write y. You don't need to write 1y. So you just say y equals to minus 20 plus 24. That gives you 4. That means our answer for y is 4. Now since we've gotten our answer for y as 4, we can now come back to this your equation 1 and 2. Substitute into any of the equations that you like. Now this is the rearranged equation 1 and equation 2. So let me use my equation 2 this time around. We have 4x minus 7y equals to minus 8. And here the answer we've got for y is 4. So anywhere I'm seeing y, I'm going to be replacing it by 4. So that means I'm having 4x minus 7 into bracket 4 equals to minus 8. So here we have 4 4x minus 7 times 4, 28, equals to minus 8. So we have 4x. When minus 28 crosses to the other side, it becomes plus. So we have minus 8 plus 28. So we have 4x equals to minus 8 plus 28 gives us 20. Divide both sides by 4. We have x equals to 5. So therefore, x equals to 5 and our y equals to 4. We've gotten our answer, but we need to check if our answer is right or wrong. So for the checking, let me use equation 1, the rearranged equation 1. So we have 3x minus 5y equals to minus 5. So my x here is 5. 3 into bracket 5 minus 5 into bracket my y 4 equals to minus 5. 3 times 5 is 15. So we have 15 minus 5 times 4, 20. Everything equals to minus 5. 15 minus 5, that gives us minus 5 equals to minus 5. So that means our LHS equals to right hand side. Sorry for the left hand side. It's not as smooth as the right. So with that, we have come to the end of the class for today. And as usual, I'm going to drop the exercise at the end of the video. And as usual, our YouTube channel, for you to get updates regularly, just search for Adiagbo Festus, and when you see the videos, you can just subscribe to the channel. Just anytime we upload videos, you'll be able to get it. There will be a notification there, so just click on it, like it, and that's all. And for the Facebook, the video will also be uploaded on Facebook as well. And anytime you finish solving, please, you have my WhatsApp number that will be displayed at the end of the video. Send the solution to me, I will mark it, and if there's any correction there, nothing stops us from correcting it, and you'll be able to solve it again. Thank you, and God bless you.
Shine and fall, for the hands of Jesus Christ is upon me. It is my turn to shine, and I must shine and fall, for the hands of Jesus Christ is upon me. Partakers of His glory, arise. Shine and fall, for the hands of Jesus Christ is upon me. It is my turn to shine, and I must shine and fall, for the hands of Jesus Christ is upon me. God's glory is upon me, testimony so strong. Because of His glory, I pray for the God. Enemies cannot stop me. I have all signs and wonders, for the hands of Christ Jesus is upon. God's glory is upon me. Testimony so sure. Because of His glory, I pray for enemies cannot stop me. I am Jesus is upon partakers of His glory. Arise and shine, children of the kingdom. Arise, partakers of His glory. Arise and shine, children of the kingdom. Arise and shine. Oh, it is my turn to shine, and I must shine henceforth. Oh, for the hands of Jesus Christ is upon me. It